the DMLS side of actual parts making is my first metal experience. And getting into that, that kind of saw the first gap. It's like, okay, you can make these really awesome, intricate parts, but they're welded to this bed. So you have to come out and either wire EDM, or cut them off with a chop saw and polish. And cycle times could be 2 hours. They could be 4 days. It's just it wasn't an economic solution for the parts business that my mind works around. I work around how do I make as many parts as my customer needs for an economical price. And the DMLS side just 7-8 years ago just didn't make sense to me. It's getting better now. 4 lasers, 6 lasers, 8 lasers. You're starting to get faster, but still applying something to a build platform and where you have to cut it off, that's still, I can't wrap my mind around that. So having a background in conventional press and sinter and metal injection molding, binder jet makes sense to me.
Hello there, Internet. My name is Adam Fosnot. I'm a mechanical engineer, and I have been working with 3D printers of all shapes and sizes for over 7 years. I've worked with machines from under $200 to over $200,000, and I have learned so much in the process. One thing I noticed is that a 3D printer tends to be judged on two extremes, one being a press release where everything is shiny and perfect, and the other being a YouTube review where a lot of times every product gets criticized. Another insight is that there tend to be two worlds in 3D printing, one being the industrial space and the other the hobby space, and those two worlds rarely talk to each other. This podcast breaks down those barriers to have a transparent, no BS conversation about the world of 3D printing and technology. I'm so happy to have you on board. Let's get started. To kick things off, could you introduce yourself to the audience?
Yeah. So I'm Chris Alio. I'm the co-founder and vice president of business development for FreeFORM Technologies in St. Mary's, Pennsylvania. We are a contract manufacturer job shop providing metal additive production using metal binder jet.
Okay, awesome. And I'm super excited to dive into everything that you guys do and offer. Before we get there, just to help people get to know you a little bit better, could you share something about yourself kind of outside of what you do for work?
Yeah, absolutely. So Penn State grad, pretty proud of that. Father of 2 boys, married my high school sweetheart. So that's kind of who I am.
That's awesome. How old are your kids?
Almost 4 and then 9 days.
Oh my gosh, congratulations.
Thank you.
That's so new. I can't believe you're in the office.
Yeah, so new baby, new company, new job. There's 24 hours in a day, 23 of them awake. So
yeah, I'm sure. Man, such a busy time. It's going to be a big year for you.
Absolutely.
So I'm excited for you. I'm one of 3 boys in my family growing up. So one of the big things I remember about having a household of all boys was we tended to wrestle around a lot and putting holes in the drywall in our basement. But
are you the middle, the oldest, or
I'm the middle child.
Okay.
So the stereotypical problem child, but my older brother's a year older, and then my younger brother is 4 years younger. Nice. We all get along pretty well now, but awesome. Some things you have to look forward to as a father of boys, I'm sure.
Yeah.
So how exactly did FreeFORM get started? I was doing a little bit of digging online. It looks like you're a pretty young company.
Yeah, so I guess we incorporated in September of last year, end of September, but we're all local to the area. We've all worked in metalworking, metal forming technologies. Our president, Nate Higgins, and myself, we ran a pretty significant metal injection molding company in the town local here. But there's a couple of guys locally that were a little bit more senior than us that were ready to start a business. They had either worked in additive or were very interested in additive. And they approached us and said, "You guys want to start your own company?" And that was something Nate and I are lifelong friends, something we've always discussed doing together. And we said, yeah, it's the height of COVID. Unemployment's 10%. Let's quit our jobs and start our own company. So it's kind of a weird time to start a business, but reflecting back on it, it was kind of the perfect time to start a business. The world was kind of at a standstill. Nobody was really doing a whole lot. I mean, people were reacting to the pandemic and trying to solve that problem. But from a business perspective, things were kind of at a standstill. We were in the metal injection molding space, and there's a lot of upfront costs with that as far as tooling and lead times. People were really cash conscious during the pandemic, so metal additive really picked up during that time, and it was kind of the perfect time to start a metal additive business. People were afraid to spend money on tooling, that they didn't know if projects were going to go anywhere, but metal additives, metal binder jet parts kind of filled that void for them.
Okay, that's really cool. I had been doing a bunch of reading, especially early in the pandemic, where tons of businesses, like even ones that normal everyday people would recognize, started during the financial crisis in 2008 and the real estate crisis. I think there's something really interesting about large economic impact events that really drive people to start businesses. So your background was in metal injection molding, it sounds like. How did you first start getting acquainted with 3D printing?
Yeah, so St. Mary's, Pennsylvania is kind of the powdered metal capital of the world. So I grew up around it, had family that worked in powdered metal. So right out of college, I kind of jumped into the conventional press and sinter world.
Okay.
And then, the company that I worked for before was trying to start a greenfield MIM company back in like 2014, 2015. And working in that, I got recruited by a larger MIM company that also did DMLS and powder bed fusion. That was kind of my first exposure to the metal additive side. Plastic additive, we were always using for like end of arm tooling, fixtures, jigs, put a part in your hands to see how are you going to process it throughout your facility. That's kind of my first exposure. But the DMLS side of actual parts making is my first metal experience. And getting into that, I kind of saw the first gap. It's like, okay, you can make these really awesome, intricate parts, but they're welded to this bed. So you have to come out and either wire EDM or cut them off with a chop saw and polish. And cycle times could be 2 hours, they could be 4 days. It's just it wasn't an economic solution for the parts business that my mind works around. I work around how do I make as many parts as my customer needs for an economical price. And the DMLS side just 7-8 years ago just didn't make sense to me. It's getting better now. 4 lasers, 6 lasers, 8 lasers. You're starting to get faster, but still applying something to a build platform and where you have to cut it off, I can't wrap my mind around that. So having a background in conventional press and sinter and metal injection molding, binder jet makes sense to me.
Okay, that's really cool hearing kind of your progression through that. I visited St. Mary's a couple times, and
oh really?
Yeah, and it's crazy to me how much industry there is, even pretty far away from like Pittsburgh and Philadelphia, some of the bigger Pennsylvania cities that I think of. But at least earlier in my career, I didn't realize that metal could come in a powder, let alone comes in so many different grades and different materials and can be processed in different ways. DMLS welds parts to the build tray, like you've said, and metal binder jetting makes sense. How does the start to finish process change from a conventional press and sinter to a DMLS to a metal powder binder jet? And this is kind of a loaded question, so we can take it one at a time here. What does the process look like with a traditional press and sinter operation? Hey there, it's Adam. If you're enjoying this video, could you go ahead and tap the like button? It's totally free for you, and through the magic of internet algorithms, it will help more people see the podcast. Thanks.
So traditional press and sinter, you're buying powder. You're buying it usually pre-alloyed, or you can mix it yourself. Most companies buy it pre-alloyed because it's more cost competitive.
Okay.
120 micron powder, say, and then you put it into a die and you compact it top and bottom. So it's uniaxial compression. So you're forming realistically 2-dimensional products, but you're forming them fast. I mean, a conventional press will press 600 to 1,200 parts an hour, depending on complexity.
Okay.
So it's a very fast process. You can move those parts right to sintering right from the press. So there's no debinding, Some of the stainless products you delube to get rid of some of the higher lubricants for the lubricity of the tooling.
Okay.
But it's a very fast process. But it's, you can only press so many shapes.
Okay.
That's kind of the downfall. Powder's pretty inexpensive, so you can make really cheap parts.
Mm-hmm.
Tooling is expensive, and you really have to get some volume to kind of economically make cheap products.
Okay. Would it make sense that you run into that same tooling versus raw material cost challenge that you see with plastic injection molding?
Yeah, it's kind of the same cost. You're weighing those same cost benefits or cost impacts, whichever way you want to look at it. It's how long can you wait to get your product to market while you wait on tooling, and how much tooling investment can you stomach to get your product to market. And that's really what we were always up against in previous life is, okay, this tool is $30,000, and yep, that seems good. We can afford that, but you'll see your parts in 12 to 16 to 20 weeks.
Okay.
And that's kind of, now I'm, on the metal side, metal additive side, your part is maybe marginally more expensive, but I can get you parts in 5 days. Do you want to go to market in 5 days or 5 months? Everybody's saying 5 days.
Yeah, no, that's a massive difference.
Yeah.
If I want to press and sinter a part, what types of constraints do I have to work around, or what's an ideal press and sinter part? I'm imagining just like a washer, which seems like a really dumb.
It gets much more complex than that. A lot of high volume automotive applications. I think the last number is there's like 50 to 60 pounds of powdered metal in every car that's on the road.
Okay.
So transmissions, exhaust, timing belts, all your VVT, VCT stuff for variable valve timing, that's all powdered metal. A lot of it's produced here locally in the St. Mary's area. There's still a lot of lawn and garden components that are powdered metal.
Okay.
That's a big industry. But you're kind of constrained to that uniaxial compaction and then added machining.
Gotcha. Okay. Typically when I see a part that has like a grainy type outer surface finish, my brain immediately goes to casting. But to your point, there's probably a lot of relatively simple components that are powdered metal. So taking one step forward from the press and sinter, how does the process change with a DMLS machine? Since that's really the type of machine that most people in metal 3D printing think of.
That's where most people's minds go to is the laser systems.
Yeah.
So laser systems are really high end. You're layering a layer of powder. You're welding that powder to the build bed to start, and then you're layering those powder layers together, which each pass of the wiper and the laser. So you have to have some way for that powder to get out after it's all lasered together. You have some size constraints. Now those machines have gotten much larger over the last 5 years. So those size constraints are a little less limited. If you look at like what GE is doing, they're making some really, really big, engine components and rocket components. But it's, in my experience, in my opinion, it's higher end materials, bigger parts, more expensive parts. I don't know anybody that's making, hundreds of thousands of DMLS parts of the same part. They might be doing that for different parts throughout the year, but for like recurring business, kind of competing with your investment casting or die casting or MIM, DMLS, in my opinion, is just not the route to go.
Okay, interesting. You said high-end materials. In simple terms, how would you define a simple material, a mid-range material, and like a high-end material when it comes to powdered metal?
So high-end materials, I think like Inconels, Hastelloys, titaniums, cobalt chrome, that kind of things, those kinds of things. Kind of your bread and butter materials for any of the metal processes are going to be 17.4 and 316 stainless steel.
Okay.
They're produced at the highest volume, so they're the most cost efficient.
Okay.
Tool steels kind of would be in that mid range as far as a cost perspective and ease of manufacturing.
Mm-hmm.
That's and then aluminum is probably the most inexpensive.
Okay, cool. When it comes to kind of those various tiers, um, are there different design considerations or sintering considerations between those? Um, I'm thinking that aluminum being relatively cheap, but also being um, very thermally conductive might pose some challenges.
Yeah, there's a very small window for sintering aluminum. There's a lot of press and sinter aluminum.
Okay.
Desktop Metal and X1 have both rolled out, releases that they're, have some diligence around binder jet for aluminum. We haven't processed any aluminum here at FreeFORM yet. It's something we're keeping in the back of our mind because there seems to be a lot of sexiness around it. But aluminum die casting and aluminum machining, those are pretty cheap processes. So how do we compete on that level it's going to be interesting to see when more of that, that due diligence is released and how we can process that material cost effective. On the DMLS side, there is no post sintering process. You're sintering or welding in the process. So you don't have any of those same considerations for that process.
Gotcha. Yeah, sometimes I forget about die casting when it comes to aluminum, because you can get some incredibly complex shapes relatively simply and quickly. So thank you for bringing that up. Sometimes I forget about that one as an option. So we've covered traditional press and sinter, DMLS, which has those limitations that you mentioned in terms of part size and part volumes. That's really practical. How does that change when you look at binder jet metal printing?
So binder jet, in my opinion, is it's the fastest printers on the market. I mean, I think I think Desktop has some diligence. They say that, it's 10 times the speed of DMLS.
Okay.
But speed isn't always quality, in my opinion.
Mm-hmm.
Just because you're going fast doesn't mean you're making the best parts. Surface finish is kind of the holdback for all of the metal additive processes, in my opinion. Part size, we're kind of limited to what we can sinter.
Okay.
Effectively. Sintering big parts is a challenge.
Okay.
The parts are round numbers, 20% bigger as printed than they are sintered.
Gotcha.
So the bigger you get, the more that shrink, it kind of compounds. So we're really working in, size of a business card by 1 inch tall is kind of our sweet spot for parts. Maybe a little bigger than that, but really we're working in more kind of the MIM part range.
Okay.
Sub 100 grams, sub 200 grams, that type of part. The printers that we have now, and we have 3 printers. So we have a shop system from DM, we have the P1 from DM, and then we have an InEvent Plus from X1.
Okay.
Both the P1 and the InEvent Plus have about a 1 liter build volume. So we're kind of limited on part size. Shop system from DM, 8 liter build size, up to 12 liters. So we can print bigger parts. But kind of our business model at FreeFORM is bigger parts aren't better. More parts in that build bed is better. That's where you get your cost efficiency.
Gotcha. So the ideal case scenario is roughly business card, post-it note size, X and Y, sized parts, higher volumes of them. How long does it take to go from a CAD file to holding a metal part in your hand?
On the volume side, the nice thing about this printing process is the printer doesn't care whether it's printing 1 part or 1,000 parts. So it's extremely flexible. I could print 100 parts of 100 different SKUs in that printer and it wouldn't know the difference. So we're not really limited by volume in the kind of conventional setup standpoint, like you would be with MIM or powdered metal or investment casting. It's all software driven. So as fast as our applications guys can get it into the software, the printer will start printing. From the time we receive an order to the time we can start printing, depending on backlog and current orders, but we can turn parts around in the printed state in a day.
Okay.
The P1 system will turn over a build box in about 57 minutes. And I say it that exact because it's that incredible.
Okay.
That's build box in, print a full build box out, load another build box, 57 minutes.
Do you want to be a guest on this podcast? If so, go to 3dprintauthority.com/forms to apply. Thanks.
So
Wow.
we're turning over a lot of parts very quickly. So the prices are being, we're starting to get more competitive with those traditional technologies. Now, I will be the first person to tell you up front, honestly, and no BS, kind of like this is all about. Just because we're doing it as fast doesn't mean we're as cheap.
Okay.
The material is expensive. Sintering is expensive. There is post-processing to get to the surface finish that our customers want. I look at the technology as a complement, not as a competing technology just yet. We're getting close, but we're here to complement those other technologies for now. If I can support a MIM company or an investment cast company that their customers need to get to market faster while tooling is built, we will do that. If my customers can't afford tooling or don't want to spend money on tooling, we can support their production volumes. But we're very much a complementary technology than we are a competing.
That's so good to hear from you, because I think that eventually 3D printing will be a far more attractive option for mass manufacturing compared to traditional methods.
Yeah.
But to your point, I don't think we're there yet.
No.
There is a place for it, for businesses to choose it, but it's not kind of the default option. So I'm happy we're on the same page with that.
I wouldn't go like door to door closing machine shops or anything. I mean, those companies are still very much needed. There's tolerances that we still can't hit. There's surface finishes that we can't hit. There's volumes that we can't achieve yet. So I don't know if we're 5 minutes or 5 years from there, but it's coming, and that's why we started this business.
Yeah, no, that's really cool. When it comes to side note, I feel like sometimes when we talk about 3D printing or automation, a lot of the traditional machine shops start to be like, oh no, the robots are taking our jobs. But it's like there is a future here where people have jobs, we just work differently.
Yeah.
And I think it's far more positive than it is negative when I look at the scope of the world and products and such.
Yeah, I mean, machinist, that's a skill. That's not a job. I mean, that's a skill. And we definitely need those jobs. We definitely need those services to support our business and this technology.
Yeah. So tell me about kind of what you guys offer and what you don't offer in terms of services. And the thing that's really sticking out to me is you've mentioned post-processing a couple times. So typically, what post-processing are you looking to do to your parts after they're printed? And do you do that internally or externally?
Yeah, so internal post-processing, we do a lot of centrifugal disc polishing.
Okay.
So high frequency tumbling. Get rid of some of those layer lines, smooth out the parts. You can get rid of the high spots, because from a dimensional accuracy part, we can hit some really tight tolerances, but you get one layer that's offset a little bit and it eats up your whole tolerance.
Oh,
so
right.
if we could run through a quick tumbling operation in one of those centrifugal disc machines, we do that internally. We also heat treat internally, precipitate harden internally. But the nice thing about being in St. Mary's is all of our suppliers are here. I mean, our heat treaters are here for quench and temper. Our coaters are here for black oxide, manganese phosphate, zinc, nickel. We have a ton of suppliers in this area. There's a dozen machine shops here to support our business as well, from cleaning up tolerances or machining some features that maybe we just can't process. So we're set up in kind of the ideal location. When we started this business, we looked at a bunch of different areas. We're all from here, but we're not afraid of moving away from here.
Okay.
So the one thing was really attractive was neighborhood 91 down in Pittsburgh at the airport. But if you take a step back and you look at our area, St. Mary's or Elk County is neighborhood 91. It's just not as sexy. It's not as sexy. My heat treater is here. My coder is here. My material supplier is warehouse material here. And the nice thing about being here is, I know those people. I can text that person. I can call that person. They respond. They know who I am. Our kids play sports together, whatever. It's, this is, we'll call it, this is the first neighborhood 91. It's all set up here.
Yeah, that's one thing I've grown to really love is driving through like an industrial area of a city. Wow, I feel so nerdy saying this right now, but driving through like an industrial area of a city and being like, oh, there's a sheet metal shop, there's a stamping company, there's a this and a that, and they're always so unassuming. But sometimes you walk in the door and they're just doing incredible things, building parts for helicopters and fighter jets. It's so cool to me.
Try being a sales guy and going on a road trip with your wife and say, hey, look that company up. Tell me what they do. Write that down. But I'm the same way. I got to know when I open every door, I got to know what's going on in there.
Yeah, I see some of our road trips differently now. So I grew up in the Cleveland area. So now when we're driving through, I'm like looking at all the buildings differently and like quietly geeking out a little bit about like all the cool stuff they must be doing.
Yeah, Cleveland's a great city.
Yeah. They've got a lot of that old manufacturing atmosphere that Pittsburgh does, and I'm sure St. Mary's does as well. To get a little bit more back on track here, where do your customers come from? And do you see most of the interest for what you offer coming from the industrial space or at-home inventors, hobbyists, some of that demographic?
I would say being 8-9 months into this now, our customers are mostly coming from the industrial space.
Okay.
We haven't had enough time to do some of the smaller trade shows like we would like to do, where we can bump into those inventors or those theorists that are out there that have, they want to make 1 or 5. Most of our customers to date, I think they're just searching for a new option.
Okay.
Their volumes are either coming down on a different technology and they're paying big lot charges to get their tooling set back up. They know that we're using a powdered metal type process, so it's validated. The only thing we're missing is like a standard to validate it around.
Okay.
But that's where most of our customers are coming from. I think they're kind of, I don't want to say displeased with their current supply chain, but I think the pandemic had made people think differently about their supply chain.
Definitely. I looked at a bunch of industry reports recently, and some of them were just surveys essentially, and the audience varied quite a bit. But some of the other ones were entirely focused on supply chain and how 3D printing is changing supply chains based on, the global situation right now. So it makes total sense to me that people are kind of cross-examining their supply chain and looking for alternatives.
Yeah.
When you're talking to different customers, what types of materials are they asking for? And the second part is what do you offer as like the full scope?
Hey there, real quick. If you are enjoying this episode, could you do me a favor and subscribe wherever you might be watching or listening? It's totally free. It helps you not miss new episodes when they come out every single week. It tells the internet algorithms to help our content reach more people, and it would really make my day. I hope you think about it. Thanks.
Okay. So most materials that they're asking for is, I think people compare metal binder jet and metal injection molding the closest.
Okay.
Because I think the marketing materials that are out there, it makes those two sound like they're the biggest competition or complement to each other. So most people are asking for 17.4, 316, 4140, 4340. Those are kind of the biggest materials that we see. The materials that we're offering today are 17.4, 316, and S7 tool steel.
Okay.
That's what our machines are set up for. It's what we have the most parameters for. That's what our most volume is in. Upcoming, we have a list of 15 different materials we're going to release this year. Some more iron materials around that 4140, 4340, 4605 is a big MIM material. So that's something we're focusing on as well. Inconel is picking up some pace with what people are requesting from binder jet. Those parts tend to get a little bit bigger. So, working with those customers to see if they have anything in that material a little bit smaller as we ramp up our equipment size. Engineers love to ask for titanium. Buyers do not like to pay for titanium. It's just, it's a whole different stratosphere as far as processing.
Okay.
But yeah, kind of your most cost-effective materials are going to be 17.4 and 316. And like I said earlier, they're atomized at the largest quantities at the material suppliers, so we get the best price on those materials.
Do you have a question about 3D printing? If so, I would love to answer it. Feel free to leave any questions in the comments down below, or go to 3dprintauthority.com/forms to submit your question. Thanks.
Gotcha. And when you're kind of talking people through their applications and the materials and the part sizes, do you find people coming from some industries more than others? Like, is it super heavy in medical devices, or is it super heavy in automotive? Is anything kind of standing out to you?
I would say medical is a big portion of our business and a big focus of our business.
Okay.
They're very, very creative. They're getting a lot of new products to market. And the interesting with medical is I would bet that 1 out of every 100 medical devices makes it to market. So there's a lot of prototyping that goes on. There's a lot of development that goes on. So there's a lot of recurring business that goes on there. The consumer market, consumer outdoors, consumer firearms, that type of thing, we see a lot of interest there because those companies use MIM and investment casting at probably the highest frequency. So they're interested in metal binder jet and how it competes with MIM or how it complements MIM, how they can get to market faster with metal binder jet while MIM tooling or investment cast tooling is being built. So we see a lot of interest there. Industrial is picking up. I think the power tool companies are interested, like fluid dynamics, airflow, those types of things. However, they can create, internal geometries. That's picking up as well. We don't really mess around the automotive space. We're an 8-month-old company. We're not there yet. I think the technology is very interesting to them. Like you said earlier, Ford has a nice partnership with Desktop Metal, so there's definitely things happening there. Just not for FreeFORM at this time.
Yeah. No, you mentioned firearms and consumer outdoors products, and my first thought is like that makes so much sense. And power tools also, they've got lots of like fairly complicated internal components that would absolutely make sense for a 3D printed powdered metal version. I want to pivot a little bit, I think, from kind of what your customers are asking for to the equipment that you're running. Because you've got a handful of machines. What made you decide on those specific machines when you look at kind of everything that's offered in powder bed, metal powder bed binder jetting? That is such a long
metal binder jet.
Binder jet. That's such a long phrase. Anyway.
Yeah. So I think, our opinion would be that X1 and Desktop Metal are leading the charge in metal binder jet. X1 has the longest history. They have several different pieces of equipment that you can purchase. They probably have the most materials on the market that you can, they have the most process parameters around. Great surface finish, great part quality. Desktop Metal is this, $4, $5, $6 billion beast that's out there. They're running with their equipment, the shop, the P1, the P50, the studio. They are really, really pushing. And I actually think those two companies are really good for each other because it's really pushed ahead. HP, GE, they have good equipment. Just doesn't really fit our niche right now. GE, from my understanding, is focused on bigger parts and bigger partner industries. They have Cummins, they have Wabtec, those kinds of things. It's Desktop Metal, I think, has the best speed. X1, I think, has the best surface quality. And those are what our customers want. So we bought systems from both companies.
Gotcha. I do like that you guys have diversified in that way and kind of done your homework from what it sounds like in kind of what each person offers.
Yeah, and if somebody from GE or HP watches this and they want to sell us equipment, I'd be glad to learn more about what they got going on, because we want to have the answer for our customers. If the equipment we have now isn't the answer, I think it is. But if it's not, we want to know what else is out there.
Yeah, and probably want to know as soon as possible.
And there's probably some people smarter than me in a garage right now making the best piece of equipment that I don't know about. So,
I don't know if you've come across them. Digital Metal. Yeah,
awesome equipment.
Okay.
but speed. that's kind of the thing. It's, their speed is very similar to X1.
Okay.
And X1 is right in our backyard. They're like an hour and 40 minutes away. Their service guys are here all the time helping us out. They take care of us. They're a great company. We work really well with them, and they're right here. Digital Metals in Sweden.
Right. I guess.
So, but awesome equipment. I know there's another company in the States that's running their equipment, and
Okay.
we run into them at some trade shows and stuff. The parts that Digital Metal is making are awesome.
Okay. No, I appreciate your take on it. As someone who runs the equipment every day and looks at parts every day, I think that's so valuable. Just when I look at all the different people offering it, it seems like no one's talking about them.
Yeah. I don't know why that is. I mean, I know, we talked to them before we purchased equipment. It just was the speed thing, and the speed and service.
Yeah.
They're getting a better North American presence, which is great long term. It's not out of the question that we'd have a piece of their equipment here. But Desktop Metal is really, really good to us. We work really, really great with their technical team. We know their people very well. They know us kind of inside and out. And X1, same thing. Their people are great. They're really good to us. They're right in our backyard. I mean, those are the two companies. It's a pretty easy decision for us to pick those two pieces of equipment.
Good. I'm happy to hear that you've had good experiences with two American metal printing companies so far. I think it's awesome. When you were trying to start the business, what made you choose manufacturing as a service compared to, I guess, trying to develop your own equipment? Or I'm going to leave it there. What made you choose that business model over any other possibility in metal printing?
Yeah, and if you look at our 4 co-founders, our history is in parts making.
Okay.
So that, jumping into that and buying good equipment, having good relationships, and having technical people here on our team that want to push the technology, that's our business model. We want to, rise the tide of metal binder jet. That's what our president Nate says all the time. It's, I think if you look at like the last Power report, there's 10 binder jet companies in the world.
Gotcha.
There should be 100, and we want to help. We want to help people adopt the technology. If we make 1,000 parts and then you buy your own piece of equipment, we make 1 part and you buy your own piece of equipment. That's a win for the technology, and that's what we want people to do.
Gotcha. That's a really cool take on it, I think. I think you're kind of taking the strategy of becoming a power user of a very promising technology very early.
Yeah, I mean, if you look at the other technologies that we've talked about, powder metal, investment casting, MIM, die casting, there's thousands of suppliers.
Yes.
Why is there only 10? Why is there only 10 binder jet companies? I mean, I hope that next year there's 20, and the year after that there's 100. The technology is here. I mean, that's the tagline on our website. The technology is here. I mean, it's not going away. It's here. We're making thousands of parts per month for customers.
Yeah.
People are adopting it. You're probably going to pick something up in the hardware store or at the electronics store. It's going to have metal binder jet parts on it. You might not know, and you might think it's junk or whatever, but it's here. You're buying it, whether you know it or not.
Man, so cool. I know we're coming up on our time here, so I like to wrap up with some higher level questions.
Okay.
One that I always like to ask is, outside of what you're doing at FreeFORM, what's one thing that you're excited about in the broad world of 3D printing? So this could be a trend that you're seeing, a specific technology that you think is really cool, or just something that you want to see more of.
I think it's probably twofold for me. I think it's the new piece of equipment that Desktop Metal and X1 are rolling out.
Okay.
We're very excited about Desktop's P50, and when we can get our hands on one of those. We're very excited about X1's release of the 3-liter, 5-liter machine. That's exciting for us because we think our vision is that more equipment dedicated to separate materials probably yields the best parts long term. So having something in that 5-liter range makes sense to us. And then I'm really excited about the adoption curve. Like I said, people are getting more comfortable with the technology. People are buying more parts. The adoption is happening the way that FreeFORM wants it to happen. We don't envision ourselves being the only, one of 10 suppliers long term. We want there to be a bigger market. We want to help create that.
Gotcha. How do you think you can get more people to adopt 3D printing more quickly?
I think when people understand the total cost of ownership portion of it, they'll start to adopt it. People are very, I think in bigger companies, purchasing and engineering and R&D work in a bunch of silos.
Okay.
So like R&D has a budget, engineering has a budget, purchasing has a budget. And R&D doesn't really care what that purchasing person has to pay for tooling long term, as long as they can get parts early. If those, if that bell curve kind of starts working together and they realize that, yes, your parts may be marginally more expensive long term, but I'm saving you 20 weeks to get to market and I'm saving you $50,000 investment because you don't have to spend on that tooling, everybody looks like a champion.
Yep.
So I think that's really what's going to kind of blend that curve. So I think as those companies start working together and breaking down those silos, the total cost of ownership piece to metal additives that's the winner.
Such a great answer. I love it. Because you're so right. Every department has their own budget and they think that's what they can spend, and they are intimately familiar with their problems, but not the problems of the business as a whole and not the problems of other silos. And I think there are opportunities, to your point, where 3D printing can solve problems in multiple silos.
Yeah.
That sometimes don't get addressed.
I think that's the winner. I use that term total cost of ownership probably, 1,000 times a day. The guys around here are probably tired of me saying it, but that's what we need to get home to buy, to purchasing people, engineers, R&D, prototypers, if it's a win for their company to work with this process earlier.
Absolutely. I got to figure out where this question should lie in an episode, because I feel like sometimes I just kill all the energy at the end here. But in the spirit of a no BS honest conversation, if you look at 3D printing as a whole, what is one thing that you don't like about it? Maybe you think it's too slow. Maybe you wish there were more materials. Maybe you wish people understood overhangs better. It could be anything.
I would say probably surface fit from a metal perspective. I'm not a plastics expert.
Okay.
We have a couple of plastics printers here that we use to kind of support our internal uses. But from a metal perspective, it's definitely surface finish and accuracy. Whether it's powder bed or metal binder jet or DED, most of these parts are getting tumbled or grit blasted or polished. So as surface finishes improve, that will be the biggest thing. That's kind of what's holding us back, is you pull thousands of parts out of the furnace and then they have to go to another operation before you can ship them. That's kind of the holdback. I think 7 months ago I would have told you it was material availability. Okay. But the work we've done over the last 6-7 months, there's more materials coming, and there's more really, really good materials coming. It's happening. So I think it took a company like FreeFORM to help push that to market.
Yeah, absolutely. I think that kind of hands-on feedback and looking at what you would have said 7 months ago versus now is such a good insight in terms of the practical nature of what a problem is. So I really appreciate you sharing that. I didn't expect that type of answer. So
it's not all gold plated jewelry, chain mills, watch cases. It's just like every other manufacturing technique. Shit goes wrong.
Yes.
No BS. Bad things happen when you're printing parts. It's the nature of the beast.
But I thought 3D printing was magic.
Yeah. Well, sometimes I feel like it is. It's we talked about inventors earlier. Some inventor sends you a part and they want one, and you're like, we'll give her a go. And it's like, wow, it makes magic. But no, it's no different than any other technology. The only difference is the upfront cost and the time. Bad things can happen. It's not a zero scrap process. it's not a perfect process. I mean, it's
just like any other process.
It's any other process. Yeah. I mean, it's, you know, garbage in, garbage out, right? It's what you put in. You have to have good material. You have to have good equipment. That's why we partnered with, you know, Desktop Metal and X1. We have great material vendors. You know, we have some of the best sintering equipment on the market. You have, it's not cheap, not cheap to get into. But it's like anything else, you take care of it, it takes care of you.
Awesome. Before we say goodbye, where can people find you? Where can they learn more about FreeFORM? And if there are any special calls to action that you'd like people to take, now's your chance.
Yeah, so our website is www.freeformtech.com. You can go there to find all of our latest information, learn more about our metal printers, our plastic printers. We have an RFQ form on there that you can fill out, or an inquiry. Newsletter you can sign up for. We love everybody to sign up for it. Trade shows, they're coming back. We'll be at them. I don't know which ones yet, but as we get a little bit freed up here, we'll be doing all the trade shows. We'd love to see everybody and, you know, start making parts for you, whether you want to do benchmark parts, production parts. If you want to buy additive equipment, metal additive equipment on the binder jet side, we'll have to talk to you and help you out with it. We're here for the technology more than anything else.
Gotcha. Thank you so much again, Chris, for taking the time to chat with me. Best of luck to you and the rest of the team in this year and beyond.
Thanks, Adam. This was great. I appreciate it.
Thank you so much for tuning in to watch or listen to my interview with Chris from FreeFORM. I think what they're doing with metal binder jet 3D printing is absolutely a step in the right direction to take 3D printing from where it's at today, being used for lots of prototypes, jigs, and fixtures, and actually take that next step into using 3D printing for production parts at higher and higher volumes. So I think what they're doing is really cool. Make sure to check out their website to request quotes if you need some metal 3D printed parts, or just to learn more about what they're doing and what they have to offer. If you haven't already, maybe you want to subscribe to this channel. Again, wherever you might be watching or listening, subscribing to the channel helps us grow. It helps us spread more transparent, no BS conversations about 3D printing, and I think that's something that helps everyone out. Thank you again for watching. Until next time, happy printing.